Here we go with lesson 10 of the Earth topic. Please remember after this lesson to go back to show my homework, click the entry for lesson 10, then complete the multiple choice quiz. Let's start today's lesson. Now this starter is from earlier in the topic, but I've taken away the words for matching. So try to remember the keywords from this topic and match them to the answers. If you get stuck, there are some clues on the next slide, so you can let it run forward a little bit, but try and do it without the words today. Pause the video, see if you can work out what chemistry word is being referred to in A to H. Pause it now. Okay, I'm going to move this onto the hint slide. Here are the words in the wrong order. You could use this to match them up. In a moment, I'll move it on to the answers. Okay, here we go with the answers. A chemical made of one type of atom is an element. B, more than one type of atom bonded together is a compound. A mixture can be easily separated. A reactant is used up in a reaction. A molecule is a small group of atoms bonded together. A reaction with oxygen is called oxidation. A chemical made of carbon atoms and hydrogen atoms bonded together is a hydrocarbon. And a product is a chemical made as a result of a chemical reaction. We will be referring to the words reactant and product quite a few times in today's lesson as we get going with lesson 10. How much carbon dioxide does burning fuel produce? Now, last lesson we learnt that burning hydrocarbons like petrol and diesel and methane put CO2 into the atmosphere, which causes global warming and climate change. But how much CO2 gets produced is the question we're going to answer today. So the Earth gives us crude oil and natural gas. We then change it into petrol and diesel and methane and other hydrocarbons. And here's some other examples. Coal or charcoal could also be used for fires. Coal can be used in power stations as well. And barbecues make use of charcoal quite regularly. There is a difference between coal and charcoal. Coal is found in the ground. We dig down to it and it is made of carbon. So it's found in the Earth's crust alongside igneous, sedimentary and metamorphic rocks. And we can dig it out, we mine it and then use it in power stations. Charcoal looks very similar. It also looks like black lumps, but it's actually made from wood. So we cut down trees and then heat them until the wood turns black. That makes charcoal fuel. So if you use charcoal on a fire or on a barbecue, it's actually made of wood, which has been charred until it turns black. So that's a bit different to a lump of coal, which is made of pure carbon, and it is, well, there might be other things mixed in there as well, but it's mined from underground. Right, now I mentioned the word carbon. Coal and charcoal have a lot of carbon atoms in there. In coal, it's nearly all carbon. There might be some impurities mixed in there, but carbon atoms are found in both coal and charcoal. And when we burn carbon, it reacts with oxygen from the air to make carbon dioxide. So burning coal and burning charcoal is yet another example of a fuel which produces carbon dioxide when it's burnt. So here are carbon atoms found in coal and charcoal. That then reacts with oxygen, which is O2, because there's two atoms bonded together in every molecule. And they then react together to form carbon dioxide, which is made of CO2 molecules. Carbon and two oxygens bonded together inside every molecule. So when we burn coal or charcoal, the carbon reacts with oxygen to produce carbon dioxide gas. Right then, carbon dioxide gas will then be given out into the atmosphere, and as we've learned last lesson, it causes global warming and climate change because carbon dioxide is a greenhouse gas. In the starter, we referred to the words reactants and products. So think about the meanings and try and decide from this reaction, this word equation at the top, which chemicals are the reactants and what are the products. Pause it now and decide. Let's look at the answer. Now, a reactant is a chemical which gets used up in a reaction. A product is a new chemical that gets made in a reaction. Now, looking at carbon plus oxygen, well, let's rewind a little bit, right? Carbon and oxygen are the reactants. Carbon dioxide is the product. So the product gets made, the reactants get used up. Right, let's check you on your understanding of those words. What does reactant mean? What does product mean? And what does chemical reaction mean? Pause the video and match the word to the correct meaning. Pause it now. Here we go with the answers. A reactant is a chemical that gets used up. A product is a new chemical that gets made, and a chemical reaction is a process where reactants are used up to make new products. The whole point of a chemical reaction is to make new products by using up reactants. Okay, let's return to this example. So if the reactants get used up, carbon and oxygen get used up. The product that gets made is carbon dioxide. Okay, so carbon and oxygen are reactants, they get used up. Carbon dioxide as a product, it gets made during the reaction. Now, the reason why we use this reaction is because when we burn the carbon and it reacts with oxygen, it also gives out energy. So it's a fuel, it gives out energy when it's burnt. Now, that carbon dioxide, as we learnt, causes the Earth's temperature to rise. It absorbs heat energy from the sun, traps it in the Earth's atmosphere, and that causes global warming and climate change. Now, scientists have an important role to play in working out how much carbon dioxide is going up into the atmosphere. So here's a graph of different regions of the world and how much carbon dioxide or how much carbon we think they're putting in to the atmosphere measured in tons. So we're not just giving out grams or kilograms, tons of carbon, 1,600 tons of carbon going into the atmosphere each year in the form of carbon dioxide and methane. So scientists help to keep track of the mass of carbon and the mass of carbon dioxide being produced. And you can see how much it has increased over the last 100 years or so. It's just going up and up and up, more and more carbon dioxide being given out. And scientists help to measure that mass. Right, measuring mass. Mass is measured in grams. So when we put something on a weighing scale and then press the 0 button, when you add the chemical, it increases the mass. And we measure that mass in grams. Now let's have a look at this example. 12 grams of carbon have gone into this container. Okay, so that's now saying 12 grams of carbon have been measured. That is the mass. Mass is how much of a substance there is measured in grams. Okay, now we could measure the mass of carbon at the start of the reaction. And the reaction involves heating it with a Bunsen burner, and that causes the carbon to react with oxygen. Carbon is a reactant, so is oxygen, so it gets used up in the reaction. Now, because carbon is getting used up, the mass of carbon is going to decrease. Let's measure it. It's gone down to 6 grams. So it started as 12 grams, it's gone down to 6 grams. That means that 6 grams of carbon were used up. Okay, now we can use this to work out how much carbon dioxide would get made. Now, here we have the simple equation for that reaction. Carbon has the symbol C, oxygen has the formula O2, and carbon dioxide is CO2. Okay, now what this tells us is for every 1 atom of C, it will react with 2 atoms of oxygen to make CO2. Now, we've used 6 grams of carbon. Scientists can work out how many atoms that is. We can then work out how many atoms of oxygen would join together and how many atoms or molecules of CO2 would be produced. So we can then predict, using our knowledge of atoms, that 22 grams of carbon dioxide would be made. So if you burn 6 grams of carbon, we can work out from the number of atoms involved that 22 grams of carbon dioxide would be made. Now, where has the extra number of grams come from? Well, it's come from oxygen. How much oxygen must have been reacted? Okay, now I want you to have a think about this and come up with an answer. How much oxygen do you think would have been reacted in order to change 6 grams of carbon into 22 grams of carbon dioxide? Have a think for a moment and then we'll move it on. Let's have a look. The answer is 16 grams of O2. How do I know that? Well, the number of grams can't just appear from nowhere. It comes from the oxygen. 6 grams plus 16 grams makes 22 grams of carbon dioxide. Okay, now that means that you have to use up 22 grams in total in order to make 22 grams in total. So the total mass in grams of the reactants is equal to the total mass of products. Now, this is true of all chemical reactions. The total mass of the reactants will always be equal to the total mass of the products. That is a rule. We're going to do more on this rule next lesson as well. It's called conservation of mass. The total mass of the reactants is equal to the total mass of the products. That's true of all chemical reactions. Now, what if we use 24 grams of carbon instead? Then 88 grams of carbon dioxide would be made. We can predict that from a knowledge of atoms. But learning about the rule that the mass on the reactant side and the mass on the product side has to be equal overall, how much oxygen would be added to make 88 grams of carbon dioxide? Pause the video, think of an answer. Here we go. The answer is 64 grams because 24 plus 64 makes 88 grams of carbon dioxide. That means there's 88 grams on both sides. The total mass of reactants is always equal to the total mass of products in any chemical reaction. Okay, let's put it into words. Pause the video. When 12 grams of carbon is burnt, that means it reacts with oxygen, 44 grams of carbon dioxide is made. Why is this? Why does the mass go up from 12 to 44? Think of an answer. Pause the video. Okay, let's see what I wrote. I said that the mass of product is 44 grams. Right? The mass of reactant is only 12 grams. So 32 grams of oxygen must have been used to make it up to 44 grams of carbon dioxide, because 12 plus 32 equals 44. Right? So 44 grams of carbon dioxide is made because the carbon reacts with 32 grams of oxygen. The mass of reactants and mass of products will always be equal in any reaction. Okay, what is the rule that we have learnt for mass in grams in a reaction? Pause the video and choose the correct answer. Is it A, B, C, or D? Let's have a look. And the correct answer is total mass of reactants used up is equal to the total mass of products made. A reactant gets used up, a product gets made, the mass of reactants is always equal to the mass of products. So the correct answer was D. Right, can you put that into your own words? Can you remember it? What is the rule for mass change in a reaction? Pause the video and think of a sentence. Here we go. The total mass of reactants that gets used up is equal to the total mass of products that gets made. That is the rule for mass in grams in a reaction. Total mass of reactants used up is equal to the total mass of products made. Okay, here's one final question before we get on with the writing task. If 200 grams of reactants get used up altogether, how many grams of product will get made? Pause the video, think of an answer. Let's have a look. It is 200 grams. If 200 grams altogether get used up, then 200 grams of product must be made, because the mass of reactants is always equal to the mass of products altogether. Okay, it is time for the writing task of this lesson. We are going to describe the meaning of reactant and product, and then summarize the rule for mass in a reaction. And then we're starting to use the numbers. Why does burning 12 grams of carbon produce 44 grams of carbon dioxide? Then there's going to be some calculations to do to test you out on that. So pause the video, write the driving question at the top of your work. Here are some sentence starters. Reactant, product, mass. Then what is the rule? Then here's an example to fill in. Then using your understanding to explain. When we burn 12 grams of carbon, it makes 44 grams of carbon dioxide. Why is that? Think about the oxygen. How much oxygen? How do we know that? Then with this one, you can copy down this table and say that if 12 grams of carbon reacts with 32 grams of oxygen, how much carbon dioxide will be formed? Then from number 3 onwards, you have to try and predict using the pattern. Okay, so look at the pattern in the numbers and try and predict how much oxygen there would be, and therefore how much carbon dioxide there would be. See how you get on with that. And again, year 7, Please do get good detail into your notes, write in full sentences, and just give it your best effort. There's always difficult things in these lessons, and if you try your best, then that is the most that anyone can expect. So just give it a good effort, pause the video for as long as you need, and complete your written work. Go for it, Year 7. Okay, I'm going to move this along to the answers. Please remember to tick things that are correct, and do feel really good about that. Feel proud of yourself for getting science correct, and write in anything extra that you didn't quite get. Here we go. A reactant is a chemical that is used up in a reaction. A product is a new chemical that is made in a reaction. Mass is measured in grams. Could be kilograms or tons, but quite often with reactions we measure it in grams. The rule of mass change is the total mass of products is equal to the mass of reactants. You can write that either way round. You can say the total mass of reactants is equal to the total mass of products. For example, if 100 grams of reactants gets used up, then a total of 100 grams of products will get made. Let's put that into action, looking at carbon and oxygen and carbon dioxide. A lump of coal contains 12 grams of carbon. When it burns, 44 grams of carbon dioxide is produced because the carbon reacts with oxygen to make the carbon dioxide. There must have been 32 grams of oxygen reacted to make it up to 44 grams of carbon dioxide. I know this because total mass of reactants used equals total mass of products made. So 12 plus 32 equals 44. Then there's 44 grams of reactants and 44 grams of products. So 32 grams of oxygen must have reacted to turn 12 grams of carbon into 44 grams of carbon dioxide. Calculating the masses, 12 plus 32 grams equals 44 grams. 6 plus 16 grams equals 22 grams. Now there's a pattern here. When they're all halving at the same time. So 12 halves to 6, 32 halves to form 16, 44 halves to 22. It's half as much. In the third example, it's half as much again. 3, 8, then 11. This one is double the first one. So 24 is double 12. So 64 is double 32. 88 is double 44. This one is a tenth of the first example. So 3.2, 4.44. This one, 12 grams is a third of 4 grams. It's been divided by 3. So this is 32 divided by 3. And this is 44 divided by 3. With this one, then, to find 1 grams, you can either take the first one and divide it by 12, or take the second one and divide it by 6, or take that one, 4 grams, and divide it by 4. And for every 1 gram of carbon that's burnt, 2.67 grams of oxygen will be used, and 3.67 grams of carbon dioxide will be formed. Very well done if you managed to get all of that. Some tricky work there. Please do always feel good of yourself for effort. There's always going to be difficult things in this work, and if you tried your best, then that is excellent. So well done for putting effort into this lesson and for writing in full sentences. What level have you achieved? Today I achieved describe, because I can describe reactant and product. Today I achieved explain, because I can give the rule for mass in a chemical reaction. Total mass of reactants used up equals total mass of products made. Today I achieved use, because I can explain why burning 12 grams of carbon produces 44 grams of carbon dioxide. And today I achieved combine, because I can predict the mass of carbon dioxide made by a variety of different masses of carbon. Very well done. If you manage to do that, that's really hard. Hopefully, always hope that you've been able to use your understanding to explain the main situation of the lesson, which today was all about working out how much carbon dioxide gets used, because it's really important to keep track of the amount of carbon dioxide so that we can tell governments how much everybody's using, so we can try and reduce it and try and get control of the amount of carbon dioxide in the atmosphere. Well done for your work today. Please remember to go back to Show My Homework and click on the entry for Earth Lesson 10. Then click the quiz. There are 10 questions, multiple choice, to quiz you on your understanding of today's lesson. Very well done for your work. That's it for this week. We'll be back next week with Lesson 11, so look out for that. And well done for your continued effort. Good job, Year 7. Keep it going. You're doing really well. Thank you. Well done. Goodbye.